Hey everyone. I unfortunately I didn't have very much time to spend on this. I didn't get very far, but I'll share with you the stuff that I have done. So the first thing that I did was around Shamir Secret Sharing. So I'll just explain quickly what that is. The idea is that you take some secret, such as a private key, and then you split that up into a number of shares. You then can give that to other people, or it's kind of a social recovery kind of thing. That's the sort of the practical use case for it. But you can share this out, and then at later times, these people can come together and recombine their shares, and it will recreate the secret. And it's based on the maths around polynomials. And what you have to do to create the shares is just get some random integers to act as the coefficients in the polynomial, and then the person splitting up the secret builds up the polynomial, where the secret is the constant term in the polynomial. And then they evaluate this polynomial at various points, and then they give out these points to different people, and those are the shares. And then later on, the people can combine these shares to get the original secret. And the reason is that you end up with a polynomial looking like this, and the secret term is where it crosses the y-axis. So it's this would be 12 here, and if you have some points from this line, then you can combine those to recreate this polynomial and then work out where it crosses the axis. So that's what I was aiming to do. Um, the problems that I had, I came across, was that one thing that was somewhat around the workflow, because I didn't want to share these. Sorry, I didn't want to store these shares that were being produced, because obviously these have to be kept secret. But then if we don't have them stored anywhere, then the users have to coordinate how to sort of come together to rebuild the secret. So that's some bits that I still haven't really worked out perhaps how it exactly should work. So I worked instead on the doing the creating the initial polynomial from getting some random coefficients, and then building a polynomial out of that, and then from that creating some shares that people could have, and then doing the interpolation, so getting those shares together and rebuilding those. So that's what I did. Then if I Well, hopefully we'll carry it on a little further. And what I would like to do next is to work out the next bit. So how we could make it a little bit more useful, in that if you have these shares, then we should be able to store them. So maybe we can encrypt these shares and then store those. But then we have the problem of how do we recombine them. So, but perhaps we can, having stored the shares, we can then get the users to sign for those, and then restore those offline and then combine those. But yeah, that turned out to be a little bit more tricky to try working that out. The kind of code, if you want to have a look at it, it's in the repo, but this is the stuff. You just quite a simple thing to evaluate a polynomial. You just have terms of coefficients, and then you can evaluate polynomials, and then a similar thing with interpolating the polynomial if you have some points on the curve. This was a little bit more problematic, because the initial way I had for doing this didn't seem to work. So this was a better one I found. So that's as far as I got, was to create the shares, work out the polynomials, interpolate that, and to recreate the secret. But then the user flow, I haven't got time to do more on that. And then because I sort of got a bit stuck on that, I worked on I did another project as well, that I or started on something else, because I had a number of ideas at the beginning, so I wanted to try a few of them. And this next one was around the idea of a sort of agreed upon universal concept of time and events that we could have, an ordering of events. And this is quite difficult in blockchains, and so we often end up with having a block producer deciding on the ordering of things, such as transactions. And one blockchain that did things differently was Solana, where they had a thing called proof of history. And so I tried to introduce this and try to use this, and I've made a start on this. And the idea behind it is that you create effectively a verifiable delay function, which is just a load of hashes being repeated again and again. And so at the end of a certain number of those, if you have the knowledge of this hash, this means that a certain amount of time has passed. Similarly, you can put an event into these hashes, which will alter the later hashes, and that means that's proof of that event having happened as well. Um, so I've started writing this, and what you need to do is store a counter and some hash values, and then every so often you can do a checkpoint, and then users can update this checkpoint. But to do this, you need to submit a proof. So I was looking at getting a recursive proof into this process, so to prove that this hashing and the updating of the counter and the updating of the hashes was all being done correctly, and then you'd be able to update the checkpoint. So the code that I've written then has some of this already. So it has the creating the hashes and the counter. Have a concept of searching this hash chain as well, so that you can go through and check that it's been done correctly. And the updating the checkpoint, I'm just working now on getting the recursive proof to go in there, so that then we can prove that the actual update is being done correctly. I also need to work out some kind of incentive mechanism for this, because it's not perhaps obvious why people would want to take part in running this continuously to provide this background issue of time. But that's that. And then just to finish off quickly, yeah, there's a link to the repo if you're interested in that. And my feedback, yeah, sadly I didn't have much time because of personal circumstances, but I really enjoyed it. I think there's lots of possibilities there. And thanks to everyone who was really helpful. Thanks to the Mina team. The things like the Discord channel I thought were particularly good. The only thing I'll suggest is more documentation would be good if that's possible. Okay, so that's my 10 minutes up, I think. So I'll finish there. Thanks, everyone.